So 40% off, sale price is 90, what was the original price of the cake. So one thing I mentioned the other day and thinking about this was sometimes with percent off or percent increase, it's nice to think about 100%, which would be the original thing. So I could make a note here that as far as percentage goes, we pay 100% minus that 40%, which gives me 60%. So rather than calculate the discount and then do a subtraction, if I just do the subtraction from 100% up front, that's a pretty easy subtraction to make, then I'm just going to pay 60% of whatever the original price was. And the result of that is going to give me that $90. And so this is a division problem because basically it says, what do I multiply by 60% to get 90? So the division version of this problem would be 90 divided by 60%. What do we have to do to the percent to actually make the calculation? We have to make it a decimal, a real number. And so that would be 0.6 in slang, or 6/10 properly read. Yeah, so if we can figure out what 90 divided by 6/10 is, then we have an answer. Anybody have a calculator nearby?
150.
What is it?
150.
150. So it looks like the price of the original thing should have been 150. Right? And we can double check that in a couple of different ways by taking 60% of 150 to see if it gives us 90, or by taking 40% off 150 and doing the subtraction, which is kind of like the slow way of doing it in comparison to this one. Questions on this yet? All right, so let's draw a picture with this information to try and set it up. I'm just going to look at the same problem in a slightly different way. So you could either draw a rectangle or a square for this. And what we do is one edge of the bar represents our percent. So I'm going to say this is going to be percent here. So 100% is the whole bar. And I don't know the original price, but it would be the same as 100% if I knew it. So I'm going to make a note of that up there. Then that 100% needs to get broken down so I can take 40% off. And a lot of times I want to make my drawing kind of accurate, so I'll mark off 10% marks maybe. So I'm going to make a mark in the middle for 50%, and then 1, 2, 3, 4, 1, 2, 3, 4. So I have it broken up into 10 equal segments to the best of my ability. And so counting back, 1, 2, 3, 4, this fourth bar from the right would mark 40% off. So this right here is the 40% off, which puts me at 60% right here, which is what I pay. That make sense? So I mark off where's 100%, where's the percent change, and then what else is going on there. Now, then the question is, well, where does the $90 go?
Mm, 60%.
It goes above the 60%. Yeah, so my dollar amounts are going to go on the top, so then I'm going to put $90 up here. Actually, I'm going to make it red to be with that red line. It's not 90%, it's $90. Again. So my $90 is that mark right there. So a couple ways to proceed from here. I can note that this distance on the top is $90 there. This distance across the bottom is 60%. Does 60% go into 90 very easily? It's not too bad. So let's just try it for a sec. Let's take 90 and divide by 60. Leave it as whole numbers. Whole numbers are nice. Isn't that going to be the same thing as 9 over 6? Okay. And that reduces a bit to what? What's that? Oh, this is, sorry, I made an error. I want to use my 10% chunks, so I just want to divide by 6. That makes it a little bit easier. So 6 goes into 90 how many times? So let's see, 6 goes into 9 once, with 3 left over. 6 goes into 30 5 times. So that breaks up my 10% chunks there, so each of them is worth $15. 15, 15, 15, 15, and so on. And we just checked, 6 15s should give me 90. So what else can I do with the 15? Just, I can multiply by 10 or just keep extending them, right? Either way works. Yeah, so multiplying by 10 gives me the 150 right away, or I can just keep writing in the 15s. Now, one catch about this way of doing it, if the number of chunks you're breaking it up into down here doesn't go in nicely, that's a little bit messy, and we could have some change to deal with, so this isn't always the best approach. But one nice thing is it kind of gives me an idea about how to set up the answer, how the numbers are related to each other. Another thing this is a picture version of the proportion. Remember we talked about proportions last class? Proportions are 2 equal fractions. So here I would write it for my proportion as part over whole. And I have, let's see. Yeah, we can do it that way. So I've got 60 out of 100 for the percents. And then for the dollar amounts, things have to line up. So the 90 has to line up with the 60. So it would be 90 over question mark. Because I'm trying to find the original amount. So the picture shows how to set up the proportion. How do we solve the proportion?
100 times 90.
Yeah, we'd cross multiply. We also have to go that way too. So that's going to give us that. 100 times 90. And then 60 times question mark. And then we just divide by the 60. And if we finish that, we should get the answer that we're looking for, which in this case is going to be the 150. And so when I'm setting up my proportion, I usually write down what kind of things go in the numerator, what kinds of things go in the denominator, what kinds of things go in the first fraction, and what kinds of things go in the second fraction. And if I make a note of all that, I can get everything in the right spot. Can we use the 40% directly here, though? The 40% off?
I did it and I got it wrong, so.
Yeah, so the problem with trying to use the 40% directly is the 40% only applies to the original price directly, and I don't have the original price. And so the often thing that's done wrong is people say, let's take 40% of 90. And the problem with that is 90 is not the original price. The 40% apply to the original price, not the new one. So that's an important distinction. All right, let's try another one of these. Let's go the other direction. Instead of mark down or sale, we're going to do a markup. So a business, for example, buys inventory. They mark up the price so they can make some money on it, and they sell at that markup price. So let's say we are in business, and we're going to have a markup of 20%. And we have, we buy items at, let's try $80. Then we have to mark it up and sell it. So let's take a look at what happens there. To apply the markup, for the amount of markup, we're just going to take our 20% as a decimal, so it would be 2/10, and multiply by the $80. So that's going to give us amount of markup. What's that come up to, do you think? $16, yeah, so the amount of markup is going to be $16. So then we add that back on, we take our $80, we add on the $16, and that's going to give us $96, which is the selling price. Now just note here, the $16 represents the 20% that we started with. What percent does the 80 gonna be then?
100?
It's 100%, that's the original amount. So the 80 is 100% because it's what we started with, it's the original amount. 100 plus 20 gives us 120%. So another way to look at this problem to come up with the selling price is if we just take our $80 and we multiply by this 120%, which would be what as a decimal? 1 2/10. Excellent. Good job avoiding slang. And if we take 80 times 1.2 or 1 2/10, we should get $96. So drawing a picture of that. So usually I start my picture with a rectangle for 100% or a square for 100%. So this is going to be my 100%. Then I have to include the markup, so I have to add 20% to this. Now I want to make it look as accurate as I can, so that means I'm going to have to break up this into pieces so I can tack on the 100% and have it look as a reasonable size. So I'm going to cut it in half. So 20%, let's draw that in a different color. It's going to be about that much more. So that right there would be 120% tacked on. The 100% was what we started with, that was our $80. And then we ended up with $96 after the markup. Now we applied a 20% markup, which was 16. So this entire space right here represents $16. Oops. And this is a pretty straightforward application. I don't really need to make a note of what each of these pieces is here, but we could play around with that. How much would each of those 10% slices be worth? What's that? $8 each? Yeah. So the two 10% slices on the end are worth 16 total, so each slice of 10% must be worth $8. Yeah, so we could make a note of that too, that each of these are $8. So the picture can be helping in visualizing it. And again, not every percent and dollar amount goes together nice. Sometimes they work out to be nice whole numbers, other times they don't. So, all right, so let's try another problem like this. And new page. Let's go with a 30% markup. And let's say that the selling price is $65. Question then would be, what is, or was, excuse me, the original price? Let's call it cost. The original cost is often called the wholesale cost. So try to solve this any way that seems reasonable, and then we'll compare answers. I'll draw a picture and then show a proportion for it. So the selling price is 65. After a 30% markup, what was the original cost? All right, so here's a picture of the problem I'm trying to solve. Anybody come up with an original amount? How much?
1950.
1950. I got a different number.
45, 50. Is
Um,
that what
I got,
I got 50 for the original.
you got how much?
50.
50. Okay, so we have a bunch of different answers. So let's just take a look. So again, if I do it similar to the other problem picture-wise, I have some object I buy, and that's 100%, the starting point. And then we mark it up 30%, so that means we add another 3 10s, 3 10%, so to get 130% total. The 65 is that 130%. The missing number goes with the 100%. Okay? So since I have it drawn nicely into chunks of 10, how many chunks of 10 does my picture have altogether? 13. So does 13 go nicely into 65? I believe it goes in 5 times. What that tells me is each of these little chunks here is worth $5. Because that's another way to get to 65. And so then 100% must be 10 chunks of 5, and so this is going to be $50 here. Ooh, that was only one good 5. That's fine. Okay. So the whole point of drawing a picture is to see if you can break the picture up into a bunch of equal chunks that represent a number you know. Once you know that, once you can do that, then you know how much each chunk is worth, and you can find any other number, provided they line up nice. Do they always line up nice? The answer is no, they don't always line up nice. A lot of times, like in business, there's going to be rounding when we work with things like this. Okay, but this one works out nice. Does anybody see how to get the proportion out of the picture?
Be 100 times 65 divided by 130. Is that
100 times 65 divided by 130. Yep, that would work. So the setup to get that, there's a couple ways to do it. We have to decide what's our numerator going to be and what's the denominator going to be. So in this case, what I'm going to do is my missing number is an original value I'm missing. So I'm going to put original in the top. In the bottom, I'm going to put new, the new price. My first column, I'll write down the percents. I know the original was 100%, and the new has to be 130%. So percents are going in my first fraction. My next fraction is going to be dollars. I don't know the original, so that's where the question mark is going to go. And then the 65 is the new price. It's going to go down there at the bottom. So I usually make a note of what kind of things go on the top, what kind of things go on the bottom. I usually try to set it up so the missing number is in the top. It's easier to solve that way, but it doesn't matter. Last time the missing number ended up in the bottom. So that's okay too. So here's, as Jamie said, we're going to take the 65 times the 100 and then divide by the 130. Come up with the answer. Next question.
2 things?
Yeah.
So we do one more?
Yes.
And 2, so I did 65 times 0.3. So I had it switched. Why?
So the problem is, so let's write it out a slightly different way. So I'm going to throw a little algebra at you. So we know we have a 30% markup. And we know that after the markup is where we get the $65. So the process to make that happen was I have some initial amount, let's call it question mark, and then I want to add on to that initial amount, this amount 30% of it, whatever it happens to be. That's where I get the 65. So the 30% has to be times the original amount, not the 65.
Okay.
Yeah. And the 65 is bigger, right? The original amount is going to be smaller, so by taking 30% of 65, you took 30% of a number that was too big, so that means your markup is too big. Okay. Now, let's look at this algebraically for a minute. That question mark, I could rewrite it as one question mark. If you have one question mark plus 0.3 question marks, that gives you 1.3 question marks. And that equals 65. So another way to get the answer is to divide the 65 by 1.3. That's another way of looking at this algebraically. But the 1 represents what? 100% the original amount. And it turns out for a lot of these problems, you really can't do them without thinking about the original amount as 100%. It comes up even if you try not to think about it. It comes up. All right, I'm going to pull one of these out of the homework because there were a couple in the homework like this. I had an easy sale one and a hard sale one and an easy markup and a hard markup, kind of like we just did here.
Can you leave that up for like?
Yes. Yep. Good, okay. All right, so this is in the homework section, homework 6.3, ratio and percent. Oh, by the way, I mentioned I added some stuff. So I mentioned last class that I didn't add scientific notation to the first homework for 6.3, so I made a new one for that. 6.4 reading I'd like you to do soon. We're going to start 6.4 today, and then I added a homework assignment to go with 6.4. Okay. So we're going to try and finish this up by Monday. And we're almost done. You guys realize that, right? This is week 8, next week's week 9, then we have week 10. So we're going to finish up chapter 6 by Monday, most likely. And that gives us 3 more class days to end the quarter. So we're going to spend a couple of days playing in Chapter 8. I'm going to skip Chapter 7 until next quarter. And then that gives us 1 day for review. So it's winding down fast. All right, let's see. This is a ratio problem. And let's open this in a new window. Oops, wrong button. A new window so I can blow it up. And these problems were near the end of the exercise, maybe way down here, not there, not there. Oh yeah, when I made, this font is so tiny, shit. Oops, excuse me, shoot, sorry YouTubers. I gotta fix that.
We're gonna block you.
The font didn't blow up with the graphic. Okay, I will fix that tonight. Those numbers are very hard to read. That's a problem. Okay, number 34 is a problem. Okay, here's one. Your store marked up a new shipment of shoes by 45%. The shoes will sell for $203. Then what? If the shoes sell for $203, what was the original cost of the shoes? I'm going to blow that up a little more. So here I have the computer draw the picture for you, and I show all the marks of 10 on there. Okay, so what do you notice about this picture and the marks of 10? Does it work out perfectly? No. Where can you see it doesn't work out perfect? The last one? Yeah. So notice I go up to 145%. So we're marking up by not a multiple of 10, but this time a multiple of 5. Yeah, so this time we have to break it up into 5% instead. So we got to think about how many 5% there are going across this. So how many 5s are there in 100?
45.
In 100? 20. That's again. And then how many 5s are there in 49? 45.
9.
9. I knew the 9 came in there somewhere. So we have 20 plus 9. So altogether, for 145%, there are 29 5s. How can we use that to come up with an answer? Not times it. Not yet.
Do the 203 divided by 29.
Yeah, take those chunks of 5, those 29 5s, and go into the 203. So what's 203 divided by 29?
7.
7. So that means each 5% chunk is worth $7. Okay, I'm going to write all this down on the board in just a second. I'm just kind of talking through it right now. Reminder, what does it usually say when you start your math problems?
Write my stuff down.
Write stuff down. Yeah, you got to write stuff down. I can only do this off the top of my head because I've done a whole lot of these. Yeah, so we take there's 29 5% in here. 29 goes into 203 7 times. So every chunk of 5% is also worth $7. How many 5% chunks are there in 100%?
20.
20, so that means there's 27s in the original one. So I think the original is 140. All right, so let's write that down and make sure that works before we type anything into the computer.
That's so weird because these problems are like multiple fractions in one weird way. Like you could set them up as ratios too.
Yes,
That's
right. And any complicated problem in math can be done many ways. It's a strange, wonderful thing about math. All right, screenshot this. So again, I want to encourage you to draw these pictures yourself. I have the computer draw them for you just to have a visual in front of you. But you also want to practice drawing them yourself. All right, so big catch here is that the 45 is a multiple of 5, not a multiple of 10. So we got to think in 5% chunks because of that. And there are 20 groups of 5% in 100. And then there, in the extra 45%, there are 9 groups of 5%. So altogether, that gives us 29 groups of 5%. That's where I get the 145. 29 groups of 5% is 145%. Okay. So if there's a nice way to break up the new percentage, then we can easily solve this by picture. So then we take our 203, we divide it by 29. Calculator says that's 7. Since that was dollars, that's dollars. So each of the 5% chunks is worth 7. So then each of the 10% chunks is worth 14. So the missing amount's got to be 140. And the problems you get on the computer, I set them up so that they always work out nice. You'll either get a nice group of 5 or a nice group of 10. And Jimmy, to get more practice, after you solve it, you can always hit, give me a similar problem. And it'll redraw a new situation for you. So I can just kind of play around with grouping, division and multiplication. Or we can set up a proportion, which is a super powerful feature, especially when these numbers don't come out nice. So let's take a look at the proportion version of this. So usually I like to put the missing number in the top. The missing number represents an original amount. And the numbers on the end represent new amounts. So for my proportions, I'm going to put original numbers in the top, and I'm going to put new numbers in the bottom. And it's a good practice when you're making a proportion to write down what kinds of things go in the numerator. Next, we've got to write a fraction that either talks about percent or dollars. What should we do first? Excellent. Let's do dollars because they come first in the picture. So the missing amount is an original, so it goes in the top. And the 203 is a new amount, so it goes in the bottom. So this is my dollar fraction. I also need to create a percent fraction. My percent fraction, the original is 100%, and the new is 145%. And usually I don't write the percent there, so I guess I'll take those off, because I made a note of that underneath what that whole thing means. So then to solve this, you could either cross multiply and divide, or just multiply the 203 up to the other side. So then on a calculator, we could check what is 203 times 100 divided by 145. I'm going to try that on my calculator. Calculator, so 203 times 100 divided by 145. Gives me the 140 that we got from the picture. Okay. If you were students in any other class, I would say pick the method of your choice and use that. But since you guys are going to be teachers, drawing pictures is a huge part of being a teacher to help communicate with people. So I'm really wanting you to be able to, given a problem like this, draw your own picture and then come up with a solution a couple ways from the picture. So with these problems in the homework, try to redraw the picture on your own, see if you can make a reasonably scaled drawing of it. Try to do it by kind of labeling the picture and picking it apart, and try to do it by using a proportion. So near the end, there's 4 problems in a row that do an easy percent off and a harder percent off, and then an easy percent increase and then a harder percent increase like this. So you can get some more practice with them. All right, and then I will fix that other problem that's not displaying properly. What else? Nobody brought up any homework questions, so we are ready to move on to scientific notation. I am going to stop this recording.